In this video, we're going to look at an aspect of policy towards innovations. In particular, we're going to look at the policy towards patents. What is a patent? A patent gives the holder of the patent exclusive rights to an invention for a limited period of time. The idea of a patent is to give firms an incentive to innovate. Without a patent, any other firm could just copy the firm's innovation, and the innovating firm would then not be able to earn a large enough profit to justify the investment. So patents, by giving the patent holder market power, have two opposing effects on welfare. First, they increase the incentive to innovate, and therefore lead to a greater rate of technical progress. But because they give the patent holder market power, they lead to inefficiency in the post-innovation market. The innovating firm will be underproducing. So we can see in the diagram that in order to provide the firm with a profit, we must also have a deadweight loss. In the diagram, QC is the perfectly competitive quantity, which is also the efficient quantity. At this quantity, there is no deadweight loss, but there's no profit. If we provide a profit by having a price above marginal cost, say P bar, then there's going to be a deadweight loss. And the larger is the profit, the closer is P bar to the monopoly level, the larger will be that deadweight loss. We have to take account of both of these effects when we design patent policy. We have to take account of the effect of changing patent policy on the incentives to innovate and on the level of inefficiency in the post-innovation market. Now, what policy instruments are there for the policy maker? Well, there are two broad aspects of patent design. There's the patent length. How long does the firm have the rights to its invention? Is it 5 years, 10 years, or forever? And there's also the patent strength. So the patent strength depends on a couple of things: the novelty and non-obvious requirements, so what can actually be patented. The patent breadth is about the coverage of the patent. So how dissimilar must a new invention be in order for it not to be covered by the patent? So if a patent has more breadth, generally it's harder to innovate around that patent and produce a product similar to the one produced by the patent holder. So the stronger the patent, the harder it is to compete with the patent holder by producing a similar product. So we have these two aspects of patent design. So what does altering these two things do? So to think about this, let's think about a situation where each period is identical. So the demand conditions in each period are the same and the cost conditions in each period are the same. So we have a profit in each period, pi, and we have a deadweight loss in each period. Now if we increase the length of a patent, then the patent holder will get a profit in more periods, and so we'll have a larger incentive to innovate. So increasing the length of a patent increases the incentive to innovate. But it also increases the number of periods where there's a deadweight loss. What about an increase in strength? Well, if the strength of the patent goes up, then the profit per period goes up, but also the deadweight loss per period is going to go up. So just as an increase in length, an increase in strength has two opposing effects on welfare. It increases the incentive to innovate, providing more profit per period, but it decreases the efficiency because it increases the deadweight loss. So in order to start thinking about the optimal patent policy, let's think about whether a perfectly strong patent is optimal. So let's consider a slight weakening of a patent from a perfect patent. So we'll start with a patent which enables the patent holder to price at the monopoly level, and then look at what effect reducing that price to some lower level, PL, has on the firm's profits and on the welfare. So look at the effect on the incentive to innovate and on the welfare in the post-innovation market. So in the diagram here, we have the post-innovation market. We have the demand curve, the marginal revenue curve, the monopoly price PM, and the monopoly quantity QM. And we're going to consider the effect of a reduction in the price that can be charged by the patent holder from PM to PL. And this is going to be a marginal reduction, a very tiny reduction. I'm going to exaggerate it in the diagram. So we have this reduction in price from PM to PL, which causes an increase in the quantity from QM to QL. Now, what effect does this have on profit? So we need to mark off some areas on the diagram. we have areas A, B, and C. The change in profit here is area C, which is a gain in profit, minus area A, which is a loss in profit. The change in welfare is area B plus area C. So we have a reduction in deadweight loss. The deadweight loss triangle gets smaller by area B plus C. So it's clear that the reduction in the price, the reduction in the strength of the patent, will increase welfare in the post-innovation market, but we also have to think about the effect it has on the incentive to innovate. So what is the change in profit, C minus A? Well, here it's approximately 0, and for an infinitesimal change in the price from PM to PL, it is equal to 0. To see why, let's consider the profit function of the patent holder. The optimal price will be at the peak, and at the peak, the slope of the profit function is 0, and so a small reduction in the price has very little effect on profit. So a small weakening of a patent has almost no effect on profits, and so almost no effect on the incentive to innovate, but increases the quantity sold by the monopolist, and therefore decreases the efficiency loss in the post-innovation market. So we've shown that a small weakening of a patent increases welfare. What about further weakenings of the patent? And also, what about changes in the length of the patent? So we're going to now think about optimal patent policy. So the policymaker has the ability to choose the length and the strength of the patent. So what combination of these two things is best? In order to go some way to answering this question, let's think about a situation that is quite simple. There's only one firm considering whether or not to innovate. The fixed cost of innovation is F, and the innovation is certain. Every period after innovation is identical, so we have the same demand and cost conditions. And after the patent expires, the market becomes competitive. So once the patent expires, the patent holder can no longer make a profit from their innovation. So in this simple scenario, the policymaker, they have their two instruments. They have their length L, the number of periods when the patent holder has market power, and we have the strength, which we can measure by the size of the per period profit. With a perfect patent, the patent holder has a monopoly, and their profit is equal to the monopoly profit, pi m. Whereas with the weakest patent, that is no patent at all, everyone can copy at no cost, we have a competitive market, and the profit is 0. So let's assume that the innovation is desirable. Then the policymaker will want the firm to carry out the innovation. And we have a constraint. The innovating firm must get profits that are at least as large as the fixed cost of innovation F. So the total profits from the patent are the number of periods with the patent, L, times the per period profit, pi. Since an increase in the length, L, or the strength, pi, is going to increase the efficiency loss associated with the market power of the patent holder, it's going to be optimal to make L and pi as low as possible but still satisfy the constraint. So it's going to be optimal for the policymaker to satisfy that constraint with equality. So the policymaker will choose a length and a strength so that the innovating firm will just cover its cost of innovation through the post-innovation profits. The optimal choice is going to be between a shorter, stronger patent or a longer, weaker patent. So to see this, let's look at the constraint. If we decrease L, we make the patent shorter, then we're going to have to compensate by making pi larger, that is by making the patent stronger. On the other hand, if we increase the length of the patent, then we can reduce the strength of the patent. So is it optimal to have a short, strong patent or a long, weak patent? So we already showed that the small weakening of a patent from the strongest one increases welfare. We can actually show that any weakening of the patent, accompanied by the required lengthening of the patent to maintain the incentives for innovation, will increase welfare. So the optimal policy turns out to be a very weak, very long patent. And we'll see this in detail in the tutorial. But to sketch the argument here, let's consider a diagram of the post-innovation market. And let's consider some price. And at this price P bar, the deadweight loss is DWL bar. If we reduce the price to P dash, then the deadweight loss is DWL dash. If we compare the size of the red deadweight loss triangle to the profit, which is the rectangle next to the triangle, we can see that the triangle is quite large compared to the profit. But if we look at the blue deadweight loss triangle, we can see that compared to the rectangle to its left, which is the profit, it's quite small. So as we decrease the price, decrease the strength of the patent, we are decreasing the ratio of the deadweight loss to the profit. So we're able to provide more profit compared to the deadweight loss, and therefore we can maintain the incentives for innovation and increase welfare in the post-innovation market. And it turns out this means that we can reduce the strength of the patent, increase the length of the patent, and this will always increase welfare.